Greetings and welcome. My name is Aaron Craig, and I'm here to show you off a game template that I've been working on for a while, free to use, but instead of just describing it to start with, let me show you what it looks like. So, this is a platformer 2.5D with full Z-axis integration with the use of tile sets. What that means is you can actually go in here, and these are tile sets, and you can move behind them, and there's dynamic depth that you can get in there. You can jump onto ones that are the right height here. You can jump over to higher ones, and there's bridges, so you can actually walk underneath some, like this. You can jump up onto those. Each one, you can walk behind a certain amount. You also have objects that you can actually interact with over here, and you can move in front of and behind things. And you've also got moving platforms like this Z platform, which actually goes up and down, which you can hop on, hop off. You've got this guy right here, which can actually push you up, and then you can get on and you can be in front, no problem. And lastly, we actually have a box here that we can drag around, and we can use it to hop on that and move there. We can also actually have this box up on these platforms, and you can push and have that fall. I don't think I have that in this specific demo here, but you can put these up here and they'll actually fall from heights and you can push them off, which is kind of cool. All of this being said, this template is available as a repository on GitHub right here, with just a little bit of what's going on inside of it. And it is totally free for you to use and fork and do whatever you want with. You can let me know, you can attribute me, or not at all. Totally up to you. This is the base movement and kind of game that I'm currently working on myself, and I could not find a good 2.5D game inside of GameMaker that really did all of the different things that I wanted it to do. So this is a very versatile project, and I'm going to explain that and show that in this video, and I'm going to show you exactly what I've done and how it all works. So if you want to build it from scratch, you totally can. This isn't going to be a tutorial on how to do it, but this is going to explain all of the systems that I use and how you have to actually start thinking about 2.5D or having a third dimension, a Z-axis, in GameMaker for you to have it work properly. All right? So if you're interested in that, then follow along. It'll be kind of just a rambly spewing my knowledge out. If you want the project, go grab it. If you have questions, leave them down below. I'll be happy to answer them. So first off, this is a very versatile project, and that is intentional because I really wanted you to be able to create any kind of level that you wanted to without too much work. So to demonstrate that, let me show you the room right here. This is the tile room that I've got, or the room with tiles in it, and I'm going to just jump over here to a blank section, and you can see on the left over here, I have all of these tile sets, and they have specific names, because part of the code will actually run through all of the layers, look at their names, and then pull out the layers that are supposed to be collided with, set their Z and their Z height, and then you can just put them in your room however you want with the proper name, and they will just work. So to demonstrate, let me go ahead and toss in a new layer, and I'm going to name this TS. We'll just call this demo. And then to activate that, the Z and the Z height, what you got to do is just put _Z, and the Z is how tall it is. So if it's up really high, it's going to be like a bridge or on top of another tile set. If it's not, it'll be on the ground. And then the height of it is what the player will collide with. In this case, we'll do 16. You have to do it in multiples of 16. So we'll just do this, and I will choose a tile set. I got 2 in here that you can choose from, but I'll go in here and let me bring up the room so I can actually access this tile set. Where did it go? Should be right there. Let me bring this up over here. Now, to kind of demonstrate that I'm not just like pulling your leg or anything here, I'm going to use one that doesn't look like it makes any sense to use. I'm going to use this one right here. It kind of fits, but it doesn't really raise up like this one would. But just to show you that you can use any tile from any tile set, okay? I'm going to use this one right here, and then I'm going to run the game. And if everything works properly, the game will just work. You can collide with it, you can move behind it, you can jump on it, and if you look over here, my Z is now 16, so I'm actually on top of it, and then I fall right behind it. You can move all the way off to the side, and you can move in front of it. So, there you go. And you can make this with any height, anything you want, and it will just work as long as you follow this naming convention that I've got. So, let's break down kind of how this works. And first, what you've got to do is change your brain to start thinking about everything in 3D, even though it's a 2D game with a 2D engine. So, first, that starts with the type of art you're using and where the collision masks go on that art. Now, if I jump over here, let's look at this box. This is probably one of the best examples that I've got for you. Okay. This collision mask right here, when you're doing this, the collision mask needs to only be on what would be the bottom part of the object that is touching the floor. So this whole collision mask can't be up here. It needs to be down here, because this is the part that the player will actually collide with, and this is the part that you can stand on. So if we look at the rock as well, this one's not as pretty or as easy to distinguish, but you can see that you're really just doing half of it. So in this case, it's 16 pixels tall because this is 32 pixels tall altogether. If you look at some of my terrible platform drawing, you can really see which section of it is meant to be collided with, and then this is like the top of it. And you can see this is a 64 by 64. That's also 64. This one's 32 by 64. So you can have any shape or size. You just really have to set the collision mask to be the part of the sprite that touches the floor. And it takes a while to get used to that. And if you try to use art that is not made in that like top-down perspective, it can be really difficult to work properly. I have a tree inside of here, and this is the collision mask for it. And so you can go in here and set a custom collision mask for every object, and you can also set a custom height that you want it to collide with. And the tree was a special one because it's so tall, but you only can really walk on the bushy part, not on the trunk right here. And so I had to change that. But the flexibility of this system allows you to put objects and tiles in and be able to use them any way you want. Yes, this comes from the tile set, but if I were to use the tile set on this, it wouldn't collide the way I want. And so I made an object for it. And what's cool is the objects you can actually put on top of tile sets, like you can see right here, and they will just know how tall they are, so you can collide with them as you would expect, and you can jump on them and everything, which is really, really cool. And the last thing you gotta know is the player. Their collision mask is different. It's only going to be on the bottom section here, even though like the rest of your torso, that's like on the ground. In this case, only this section of the player is actually going to collide with stuff, and this is important to set right here. Everything else you set for basically half of it, or maybe like in the case of the tree, a very specific amount. Okay. So that's how the collisions work, because these are actually three-dimensional objects that go up in the world. And if you can't get your mind around that, then play around with this, bring in some objects and tiles yourself, and see how long it takes. Because it took me a long time to get it. So don't feel bad. And if you do get it, then you should feel great, because it took me ages to really, truly wrap my mind around this. Now, let's jump through the code, because there's quite a bit here. The script Z-axis game template. This is where I have done what I hope is a useful thing in making the game as flexible and easy to use as possible. So actually, before I jump into that, there's a lot of functions in here. Overall, there's only about 400 lines of code with a good chunk of comments in here, which I hope will be helpful. And let me go to my player object, okay? So the way this works is my create event, you call the function define player controls, and you can pass in how you move up and down, how you jump, and how you interact with something. And then that's what you're going to use for the rest of the game. And so this is really easy to set up. You don't have to understand much to put in your own object and try it out yourself and make your own little game really quickly, because you're going to use this function here. Then you're going to define the player movement. And so the options are your walk speed, so how fast, your jump height, how high you're going to go, the gravity inside of the game, and if you want to have any coyote time. And coyote time allows you to jump even after you fall off a ledge. Okay, so all of that's built in for you, and you can just choose what those values are. And then finally, you just have to set how big your tiles are. Most are 16 by 16. Some are going to be bigger, some will be smaller, but this will allow you to use different sized tile sets, which I have not tested personally, but I've coded it so that it should work. If it doesn't, well, let me know. You do also have to define a camera, but this is set in a different object, which I'll show in a second. Then we jump into this object, init game. And what this does is you define the camera, so you give it the size, so the width and the height of the viewport and the camera, the room you want to begin in, because this project starts in what's called room init, which is an empty room, which just has this, so that this object can actually initialize the camera for the rest of the rooms, because that's kind of important. And then if you want the game to be full screen, and how fast you want the camera to follow the player. So all of that is customizable. And then in the room start, you set the camera, because it sets the camera for each new room that you move into. So you can have as many rooms in your game as you like. Now, let's jump over to that Z-axis game template and really dive in here, okay? So we've already seen define player controls. We have already seen define player movement. And now let's look at what the function define tile layers does. So my big push on this template was to be able to use tile sets. Because I really want to have a lot of rooms in the game that I'm going to be making, I needed tile sets to work. And so that's what I did. The way that I did it was, first, we're going to set the size of the tiles. Then we're going to set tile collisions dynamically. And what I just mean by that is when we lay out our room like this, I am actually going to go in before the game starts, when the room begins, okay? And it's going to look at every single square, and I'll show you this because it's actually a 16 by 16 because that's the size of our tiles, okay? The game is going to look at every single tile, and if there is a matching tile in a tile set in one of these ones that we have named, it's going to recognize that, and then it's going to replace that tile, or not replace, well, yeah, essentially replace. It's going to create an object called obj tile drawing right here where it is. And then for every single one, it's going to do that throughout the whole room. So there's a lot of objects, okay? There's a lot of objects inside of here. And then what that tile is going to do is it's going to draw the tile that it's at, but now we're going to actually be able to collide with it, and we're going to be able to move behind it so that we can actually walk behind tiles and underneath tiles. So let's jump back to the code here, because I'm getting ahead of myself just a little bit. So this right here is going to go through every single layer that we get from the function layer get all, and it's just going to figure out which ones we actually want. And it checks that for, has to say TS, and you have to have the _Z. So if you have those things, it is a tile layer that you are supposed to be able to collide with. Then we filter out every other one and get rid of them. Then we hide every other layer because we don't need them, or every layer that we just saved. So the objects that we create will be the ones actually drawing the layers. And if you want to see that in action, we can actually go here to this object, and if we draw self, you'll actually be able to see all of the tiles here. Now, I'm going to talk about these ones here in a minute, but for right now, all of these, you can see, these are what we actually collide with, and they allow us to go under, collide with, get in front of, and get behind of exactly the way that you would expect to in a game. and I pressed F6 and F5 at the same time. Nice. Okay, so that's how that works. Then, defining a camera. If you don't know how cameras work, this isn't the tutorial to teach that, but that's what this does. Creates the camera for you. We set the camera. Oh yeah, you can also zoom in and out just with the mouse wheel right now. So this was really useful. And this does matter actually tremendously because if you'll notice the FPS, like if I zoom out, the FPS on this drops below 1,000. And then if I zoom in, ooh, you can see we're at over like 3,000 FPS now. And that's because all of the objects outside of this viewport are not being rendered. They are not doing anything at all. And so there's a little bit of optimization happening behind the scenes to make the game run smoother. But camera controls, that's pretty useful, okay? Camera update is how we move the camera, and this is how we activate and deactivate everything outside of the camera right here. Again, not a camera tutorial. This right here is a pretty large chunk of what we are doing, okay? I got a lot of this right here from this video. Let me just go ahead and bring it up. So this guy, Mirth Castle, I was watching through his stuff, and what I was trying to figure out was how to do depth sorting on tiles. And this was super useful, okay? So this is what allowed you to actually do really good depth sorting really quickly inside of GameMaker with lots and lots of objects. And he's also got the instance activate and deactivate inside of his code here. And I highly suggest you watch this video because it really actually spends a lot of time talking about how depth sorting works in GameMaker. Fabulous tutorial, okay? So what that does is what I'm going to do is I actually create a depth sorting system right here using a couple layers called sort end and sort begin. All of the layers that we're going to use live in between those. And after those are made, I'm going to go through and search every single 16 by 16 square. And if it has a collision tile in it, I'm going to create a tile drawing object. And I'm going to get all the properties that I need for it. So how high it is, where it lives, the tile it's supposed to draw, all of that information. And then it's going to set all that information, and it's going to update the layer. This function we haven't looked at yet, but this is how you do all of the depth sorting inside of GameMaker, okay? So this right here controls all of it. If we jump over to it, it's really simple. You just check the Y and the Z, because this is a 2.5D game, and then you put it inside of your global layer grid, which is inside of the room between sort end and sort begin, and then GameMaker automatically organizes and sorts those for you based on their layer, which is super great and takes care of a lot of the work. We're not setting anything equal to the B box bottom of anything. This is really efficient, and it's a system that just works really well. The only custom thing I'm doing right here is just making sure that if I'm under a bridge, I do change a little bit of its layer because it needs to be higher so the player doesn't like pop underneath of it. And then you can get on top of that bridge as well, okay? So there's a lot happening here, but basically every tile gets replaced with a tile drawing instance or an object, okay? And then right along with that, okay, when these get created, at the end of it, they're going to go through and they're going to see if there is a tile above them. And so what I'm doing is I realized that I needed to be able to actually have a way to go and collide behind tiles. And the efficient way that I came up with, way that didn't make creating rooms really difficult, was this second object called obj top tile. This, I'll put in here, draw self. This object, what it does is it is a tile only on the top of all of these, but it's also based on the height. So this is a 48 height tile layer, which means there's going to be 3 of them because you can walk behind these. And that's the whole point of the top tiles, is we can actually move behind them. And so for the height of everything, you create them. So this is a 32 height, so you can go, there's 2 of them there, there's 3 here, and there's 1 here. And so you can actually kind of move through these tiles, and these get updated depending on where they're at and how high up they are. And these 2 objects are how we actually do all of the tile collisions inside of this project, okay? Those 2 are really the magic. I'm not going to spend much time here. This is pretty simple movement. I normalize diagonal speed so that, you have a nice feeling movement. This is your Z-based jumping. And so you're getting the floor of what's underneath you. So it's called Z-floor. And that's basically just how high is the thing underneath the player. And so that uses a function I wrote right here, where it just gets whatever is underneath of us and returns that object's height. And with that, if we are on top of something, then we update what's underneath of us. And then, to check if we're on the ground, we check to see, is my current Z, how high I've jumped up, equal to my Z floor? And if it's true, then we're on the ground. And if we're not on the ground, then we are colliding with something and we're falling down. We can jump. We have coyote time completely through time sources, which I thought was pretty impressive and kind of cool. We also fall back down with gravity. We can land on the floor. This is what the code to push boxes around. Nothing really fancy happening here, just allows us to push. The thing that happens, though, that we do need to look at is player collisions, which is a custom function. And this uses another custom function called collisions 3D. And this is the heart of collision checking in a 2.5D game. This comes from Matharu, who made a full video on it. Let me see if I can just pull that up. His video is what I watched to be able to do this. He does a really fantastic job at it. Here we go. So this is his video right here, where he goes through this code. I've modified it a little bit, but for the most part, this still works really well. And he's got some really good visuals in here. The visual that is really, really good is this one right here, describing how you actually check this function rectangle and rectangle. I highly encourage you to watch this video. I did about 8 times while making this whole template. I just had to keep coming back to it. But essentially, what we're going to do is we're going to check to see a normal collision along the X and Y coordinates as you would normally expect. If there is a collision there, then we're going to do a rectangle and rectangle check, and we are going to then see if we're colliding with that third axis, which is how that works. Okay, so the rectangle and rectangle collision basically starts on the ground, so the 0, and then it goes the Z height of whatever it is. And in mine, I had to subtract 0.25 because my collision function was returning true when I was basically the same number, even though I was like kind of on top of it. I think in regular pixel perfect platformers, you're like 1 pixel above it. In mine, I was basically on the same pixel, and so I had to check minus 0.25 so that it wasn't returning that I was inside of that, okay? So we're going to check the Z of whatever it is that we've got plus its height against our Z and our height. And so you can imagine those 2 rectangles, they both start basically at the bottom or up here, whatever you want to look at. But if they match, if there's a collision there, it's going to return true. If there's any collision. If there's not, then we are not the same height. Either we're above it, we're below it. Whatever the case, there's no collision. And so then we will return false. If both are true, then we're going to return that there is a collision. And then you have 2.5D Z-axis platformer collisions working the way you expect. What the player collision function does is just check X, Y, Z and diagonal collisions, and just does the normal collision checking as you would expect from most platformers. Here's the event to delete the top tiles, which is what that does. Let's go. Actually, yeah. That's really About everything you need to know. That's basically it. I know that was a lot of rambling. It's not my normal tutorial or walkthrough. This was just a really big project that I've been working on for a couple months now, and I'm really proud of it. And honestly, I want to see what other people are going to do with it. I want you to take it and I want you to create something. I want you to add to it. And if you find bugs and errors, then I want you to fix those or let me know. Do a pull request if you know how to use Git and let me know, and we can work on this and make this a great template. Because I know a lot of people really enjoy that 2.5D game. Crosscode is one of my favorite games. I love it. But even in Crosscode, you can't actually jump. You actually just run against something and then you go up if you're allowed to. In this, you have full platforming capabilities, which gives you a lot of responsibility. I know a lot of games are actually shying away from jumping, which is crazy because it's so awesome, but it also introduces so many problems. So, I hope you liked it. I hope you learned something, and I really hope you take this project and you do something with it. I really want to see it. Tag me, let me know. I'm excited. But that's what I've got for you today. So thanks for sticking around this long, if anyone did. And as always, keep making, keep learning, and I'll talk to you later.